Welcome to Eureka Math. I'm Mr. Shankel. Going to be helping you today with Module 4, Lesson 14. Let's get started. Okay, our job is to find at least 4 solutions to graph the linear equation 1x plus 2y equals 5. So we're just going to choose some numbers for our variables and solve for the other variables. So let's put a 0 in for x. When we put a 0 in for x, 1 times 0 is 0, so we get 2y equals 5. And then we can solve that. Let's do that down here in our space. 2y equals 5. We can multiply both sides by the reciprocal. And when we do that, the 2's cancel. We get y equals 5 halves. So y is 5 halves when x is 0. There's 1 point. Let's make y 0. That'll be easy. So if we put a 0 in for y, we get x equals 5. So that one, I like that one. X equals 5 when y is 0. So that works. Let's put a 1 in. Maybe a 1 in for x. We would get 1x. 1 times 1 is 1 plus 2y equals 5. So that gives us the equation 2y plus 1 equals 5. I'm going to subtract 1 from both sides. I get 2y equals 4, and then multiply by reciprocal, and we get y equals 4 divided by 2 is 2. So when x is 1, y is 2. There's another one. Let's just put a negative in there just to see what happens with that one. If we put a negative 1 in, we get negative 1 times 1 is negative 1 plus 2y equals 5. And that's 2y minus 1 equals 5. We would have to add 1 to both sides. That gives us 2y equals 6. Multiply by reciprocal. And that gives us y equals 6 divided by 2 is 3. So y is 3. Okay, so now we can plot those points, those ordered pairs. 0 to the right, and that's 2.5 up. So 0 right, 2.5 up is going to be right in there. 5 to the right, 0 up. 5 right, 0 up is right there. 1 to the right, 2 up. 1 right, 2 up is there. That's 1 right, 2 up. And then 1 to the left and 3 up. 1 left and 3 up is going to be right there. And you can see that we have a line. So there's the 4 different possible solutions for that linear equation and the resulting line. All right, number 2. Find at least 4 solutions to graph the linear equation 1x plus 0y equals 5. Well, let's do that. Let's put a 0 in for x. That's not a pen. If we put a 0 in for x, we would get 0 plus 0 times y is 0, and that is 0 times y is 0, and that is equal to 5. So when x is 0, y is 5. Okay. All right, and then let's say that y is. Wait a minute. This that doesn't make any sense. 0 plus 0 does not equal 5. So let's back that up. That doesn't help me at all. Let's say that y is 0. Let's say y is 0. If y is 0, we get 1x plus 0 times 0 is 0, and that's equal to 5. And then, well, that's just x equals 5. So there we go. If y is 0, x is 5. And doesn't it make sense, no matter what we put in for y? Let's say we put a 1 in for y, we would get x plus 0 times 1, well, that's 0. That's equal to 5, so x equals 5. If we put a 2 in for y, x plus 0 times 2 is 0. That's equal to 5, so x equals 5 again. And let's try a negative number, maybe negative 2. X plus a negative 2 times 0 is still 0, and that equals 5, so x equals 5. So no matter what we put in for y, we get x equals 5. And here is the graph of that equation. Let's put a 5x and a 0y, that's there. 5 to the right, 1 up, 5 to the right, 1 up is there. 5 to the right, 2 up, 5 right, 2 up is right there. And then 5 right and 2 down, 5 right and 2 down, that one's right there. So we do get a line. And what kind of line is this? Well, that's a vertical line. So really, this part of our equation was meaningless. It didn't help us at all, actually. Anything I put in for y is going to go away. So I can really write this equation as x equals 5. Because no matter what I put in for y, it became a 5 for x, and there was no changing it. So when you get an equation that says x equals something, well, you're going to get a vertical line. Okay, number 3, what was different about the equations in exercise 1 and 2, and what effect did this change have on the graph? Well, if you look at the two equations that we have, 1x plus 2y equals 5, and then we have 1x plus 0y equals 5, the change is that coefficient in front of the y. And then you can see the graphs. When we had a 2 as the coefficient, we got this diagonal line here. And when we took that coefficient out, we made it a 0, we got a vertical line. So what we were saying earlier was this really is nothing. It's anything I put in for y is going to be a 0. So it's really just 1x equals 5. X equals 5. And whenever you get an x equals a constant, you're going to get a vertical line, and that constant's going to tell you where the vertical line will be. 5 to the right. If it was x equals negative 5, it would be shifted 5 to the left. All right, so let's check this one out. X equals negative 2. Okay, so if x equals negative 2, what if y was a 0? Well, x equals negative 2. Negative 2. What if y was, I don't know, a 2? Well, x equals negative 2, right? There's no y to put in there. I can't change anything. It's still negative 2. What if y was a negative 2? Well, it doesn't change anything. X equals negative 2. And finally, I don't know, let's try 57. X equals negative 2. It doesn't change anything because there is no y to substitute for. So no matter what, x is going to be negative 2. There's nothing we can do about it. Negative 2, 0, that's here. Negative 2, 2, that's there. Negative 2, that's there. And negative 2, 57 is somewhere, way up there. But it doesn't matter because all of these points are going to be in a line, and the line is vertical. So when I get an equation that says x equals something, that's going to be a vertical line. We should be able to recognize that. Okay, here's another one, x equals 3. Well, again, we could play around with this and throw some numbers in for y, but it really doesn't matter. Let's go 0, 1, negative 1, and 5. Okay, if we put a 0 in for y, x equals 3. If we put a 1 in for y, x equals 3. If we put a negative 1 in, x equals 3. If we put a 5 in, x equals 3. X is always 3. There's no way around it. X is 3. So 3 right, 0 up, 3 right, 1 up, 3 right, 1 down, 3 right, 5 up. We get that vertical line again. There it is. All right. Number 6. What will the graph x equals 0 look like? Well, I don't even need a table here. I know no matter what I put in for y, x is 0. So I could have a 0, 0. I could have a 0, 5. I could have a 0, -5. I could have a 0, 8. X is always 0, so what kind of line do I get? A vertical line, and what's unique about this vertical line is it's on the y-axis. So x equals 0 is the y-axis. Number 7. Find at least 4 solutions to graph the linear equation 2x plus 1y equals 2. Okay, so this time we've got some coefficients in front of our variables, so let's see what we get. Let's put a 0 in for x first. 0 times 2 is 0, so we just get y equals 2. Okay, that was an easy one. Let's put a 0 in for y. That's always easy because we would get 2x, and then 1 times 0 is 0, so that's gone. So 2x equals 2. And then if we multiply by reciprocal, we can get our answer for x. So that's 1 over 2 multiplied by 1 over 2. And we get x equals 1. So x equals 1. Okay, that's good. And let's put a -1 in for x. See what happens. 2 times -1 is a -2 plus y equals 2. So let's see, -2 plus y equals 2. I would have to add 2 to both sides, and that would get me y equals 4. Okay, there's another ordered pair. And I like that x. I'm going to stick with that. That was easy work. So I'm going to put a -2 in, and 2x times -2 is -4 plus y equals 2. And let's see, -4 plus y equals 2. I'd have to add 4 to both sides. And that gives me y equals 6. Okay, so when x is -2, y is a 6. And then we can plot them. So 0 to the right and 2 up. 0 right, 2 up is there. 1 right and don't go up or down. 1 to the right and stay there. So that's right on the x-axis. Left 1, 4 up. Left 1 and 4 up is there. And then left 2 and 6 up. Left 2 and 6 up is going to be there. So there's our line. I'm going to start it there and run it that way. Okay, so you get the idea. There's our line. And, all right, diagonal line. We've seen those before. Very good. Number 8. Find at least 4 solutions for 0x plus 1y equals 2. So let's put a 0 in for x. If I put a 0 in for x, I get 0 times 0. That's 0. And then y equals 2. Okay, so if I put a 0 in for x, y equals 2. What if I put a 1 in for x? 0 times 1 is 0. I get y equals 2. Okay, I've seen this before. If I put a 2 in for x, 2 times 0 is 0. That's y equals 2. Okay, and what about a negative? A -2 times 0 is 0, and I still get y equals 2. So no matter what, this time, no matter what I put in for x, y was always 2. So let's plot these and see what they look like. 0 right and 2 up, that's there. 1 right and 2 up is that one. 2 to the right and 2 up is right there. And 2 left and 2 up is there. And this time we get a horizontal line. So really, we can look at this equation and say that 0x is nothing because no matter what I put in for x, it's going to multiply by 0 and get 0. So my equation really here is y equals 2. Y equals 2. Okay, number 9. What was different about the equations in exercise 7 and 8? And what effect did this change have on the graph? Well, here are our 2 equations. We've got 2x plus y equals 2. That produced our diagonal line. And then 0x plus y equals 2 produced our horizontal line. And the difference here is the coefficient in front of the x. We had a 2 in the first and a 0 in the second, and we've discovered that no matter what value I put in for x, I have to multiply it by 0, and that's going to give me 0. So this real equation here is y equals 2, right? The x part is meaningless. It won't change anything. So you should notice that when you get an equation that says y equals a constant like this, you're going to get a horizontal line, and it's going to either push it up like it did this time, or if it was y equals -2, it would push it down 2, and we'd get that line. Okay, so when you see x equals something, that's going to move left or right, giving you a vertical line. And when you see y equals something, that's going to move you up or down, giving you a horizontal line. All right, number 10, graph the equation y equals -2. Okay, well, what if x is 0? Well, y equals -2. What if x is a 1? Well, y equals -2. And I previewed this one, didn't I? Y equals -2. It just doesn't matter. I can put in anything for, let's put in -10, y equals -2. It's just always going to be -2, and actually we get the line that I showed you earlier, and let's just plot them. 0 right or left, down 2, that's there. 1 to the right and 2 down, that one's there. And 2 to the right and 2 down, that one's there. And then 10 left and 2 down, that one's going to be all the way out here. And when we get that vertical line that is always at y equals -2. Number 11, y equals 3. Well, I really don't even need, I could put anything in here, right, for my x value, 0, 5, -7, 9. Really doesn't matter because y is always 3. And since I know that, I can just pick a point and put y, that's 3, y is 3. What if x is a -10, y is 3? What if x is 5, y is 3? What if x is a -7, y is 3? It just doesn't matter. It's always going to be y equals 3, and we get another horizontal line. Number 12, what will the graph y equals 0 look like? Well, y is always 0. No matter what x is, I'm not going to go up or down. So if x is -8, I need a pen. If x is -8, y is 0. If x is -4, y is 0. If x is 0, y is 0. If x is 3, y is 0. No matter what, y is always going to be 0, and the type of horizontal line I get, this one happens to be the x-axis. So whenever y equals 0, that's the x-axis. All right, that is lesson 14. I hope that helps. See you next time.